On example 3, let's take a look at this pattern and notice there is exponential. Because if I take 100, 100 divided by 400, that'll be 1/4. 25 divided by 100 is 1/4. 6.25 divided by 25 is 1/4. 1/4 of 6.25 is 1.625. So this is exponential. So that follows our formula. Y equals A times B to the x power. On this problem, B is 1/4. That's what we're multiplying by. And we're going to use a pair of points to find A. I like 104. So let's go ahead and do that. So Y is 100. And then B is 1/4. And we're going to raise that to the x power, which is 4. Or 100 equals, I like to write my variable seconds. So 1/4 to the 4th power is 4 to the 4th. Got to think about that for a second. I know 4 to the 3rd is 64. So what is 4 to the 4th? And that is 256 times A. Well, let's multiply both sides by 256. So 256 times 100 is 25600, or 25,600 equals A. So now let's write our formula, or equation. Y equals 25,600 times 1/4 raised to the x power. Now, our first 3 examples are all nice and pretty. They all matched up to a equation that we could find and solve. But what happens if it's not, you can't tell it, because real life isn't pretty. Our data isn't pretty. I'm not adding the same thing to both sides. I'm not multiplying. There's not a common ratio because it doesn't quite fit everything. It's kind of close, but it doesn't fit everything. When that happens, we're going to do a little guessing and checking. First, we're going to graph it. So let's take a look at our graph here. I already put the graph in to save us some time in Google Classroom. It's in your LT8 seminar. Remember, to get this table, I press the plus sign, I put in my table, and notice it's X1, Y1, and then I can adjust my window to see it. Now, when I look at this, I'm pretty sure it's not linear. That one I'm pretty sure on, because I can kind of see the curve there. It kind of looks like it could be quadratic, but I don't have the second half of the parabola, do I? And it might be exponential, but I can't see the asymptote of where it goes. So we're going to do some guessing and checking. To me, that kind of looks like it's quadratic. So here's what we're going to do. We're going to do the same thing we did with linear way back earlier. Remember, to have decimals tell us the equation, I go y1, because that's the table that likes to use y1. And then we're going to use our tilde instead of an equation sign. And then the formula for quadratic is ax squared, so I'll go a, and then I'll go x1 squared. Oh, there's my parabola, isn't it? Plus b, x1, plus c. And then if I get rid of, now what I'm really interested in here, well, first of all, I got my equation, okay? A is about 1.07, B is about negative 2.6, and C is 10. What I'm really interested in is that R squared. See that R squared? It says 0.998. That's what we call the coefficient of determination. What it means is 99.8 of the variation in my Y value is explained by my variation in my X value. But like I said, that's a pretty good guess. Let's guess and check. Let's also check to see if it's exponential, because it kind of could be exponential. So once again, I'll use my formula for exponential. So y1 tilde, I'll go a, and then b times b to the x power. So let me see here. Here's my b. And then I want my exponent, and I'll go x1. Notice on this screen, it's green. Oh, look at that. That's even better. No, it's not better. It's pretty darn close, isn't it? 0.9979, 0.998, 0.998 is a little bit higher, isn't it? So exponential, my first guess was pretty close, wasn't it? So I'm going to write my equation. So I'm going to say A is about 1.08. So when I write my equation, y equals 1.08 x squared minus, bring that back here, what do I do with it? Here we go. Minus, plus 1.33 x and then minus C. Oh, did I look at the wrong one? I looked at the wrong one, didn't I? Minus 2.59x plus 10. I had the minus sign right. Plus 10. Once I determined it was quadratic, probably should have just got rid of the exponential so I'd be less confused. And there we have it. You notice those data points line up pretty darn well to that parabola. So this would be a quadratic model with that equation. And then we could use some predictions. I could use that model, predict how much millions they had in 2006, 2016. I won't go too much farther because we know a lot of things can change. I could find like 2011.5. Now this data, since 2007, is year one. We're actually started in 2006, aren't we? So my y-intercept would be 2006. So in 2006, we would predict they had 10 million. And so on. And there we have it.